Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter separation of substances. So in this session, let us see introduction of this chapter. In the day-to-day life, there are times when one needs to separate a useful substance from a mixture. This is done by using various methods of separation of substances, isn't it? So these necessities we might have to face in our daily life. We'll be getting some substances, so they may contain more than one kind of substance. We need to separate them to get the useful component from that. So for that purpose, we do follow certain separation methods for getting that useful component from that mixture given to us, isn't it? So about these separation of substances we are going to discuss in this chapter. We separate components in mixtures for different purposes in our daily life. Yes, for different purposes we follow these separation techniques in our daily life. For example, we remove small stones from rice before cooking, isn't it? We observe in the kitchen our mother will be separating small stones present in the rice before cooking it. We remove worms and husks from the flour by sieving before preparing roti and chapati. These all, isn't it? So from the flour, the small insects present in it and even husk, whatever are the impurities present in that, will be separated from the flour by using a siever. Similarly, we separate impurities from water and even tea leaves from the tea, etc. These all will come under separation methods. We need to separate the unwanted particles present in the useful substances. These we call as separation techniques. Okay. First of all, what is a pure substance and what is a mixture? Let us see here. Then we can see how to separate the mixtures. So pure substance means a substance which in which each particle of the substance has same unique properties. That means the substance which contains only one kind of particles in it is called a pure substance. For example, if we say distilled water is considered as a pure substance as each drop of it contains only water molecules. No other substance will be present in the distilled water. Only water molecules are present. So I can say distilled water is a pure substance. Not only this, the substance which is containing only one kind of particles in it is called a pure substance. Okay? Then what is a mixture? A substance which is composed of two or more pure substances in it, in which each component retains its unique properties, is called mixture. So, we told the pure substance means the substance which contains only one kind of particles in it. Then it is called pure substance. If a substance, if it is having more than one kind of particles in it, then it is said to be a mixture. Even though it containing more than one kind of particles in it, those particles will retain their properties, though they won't change their properties, just they will be in the mixed position. Then it is called that resultant substance is called mixture. For example, air is a mixture of several gases, isn't it? Yes, we know air contains so many gases in it: oxygen, nitrogen, water vapor, carbon dioxide. So, in this way, air is a mixture of these all gases. All the gases they have their own properties. In the same way, water which we drink is also a mixture, isn't it? Yes, actually, we are not drinking the pure water. Pure water is called distilled water actually. But the water which we are drinking is not pure chemically because it contains some dissolved gases like oxygen and carbon dioxide, and it also contains some dissolved minerals like sodium chloride and some other salts of magnesium and calcium. So these all are present in the water which we are drinking. Then only it is suitable for drinking actually. So this water is called potable water. So potable water is not a pure substance chemically. It is a mixture of some other substances along with water. Okay, these all will come under mixtures. Now, how many kinds of mixtures are present? So mixtures are of two kinds based upon the composition of the components in it. Mixtures can be classified into two types. One of them is homogeneous mixtures. The mixtures in which different constituents are mixed uniformly are called homogeneous mixtures. For example, if you see here green tea or lemon tea is shown here, it contains more than one kind of substances in it, isn't it? It contains water, some decoction, and some lemon juice, and even some green tea decoction will be there in that, and some sugar will be added often. So the mixture of these all it is, but it seems like one component, isn't it? It seems like a brown liquid. So this kind of mixtures which are having the uniformity of the components, the mixtures in which different constituents are mixed uniformly are called homogeneous mixtures. A homogeneous mixture has a uniform composition throughout its mass. Yes, if you see the composition of the decoction water and sugar at the bottom, however it is there, the same composition will be at the top also. So there will be uniform composition in the entire mass. Such kind of mixtures are called homogeneous mixtures. It has no visible boundaries of separation between the various constituents. Yes, there is no boundary. Visible boundary won't be existing for this kind of mixtures. See, are you able to identify the tea decoction separately and water separately and even sugar separately in this? No, we are not able to see them separately. All will be mixed and seems like one component. These are called homogeneous mixtures. So these homogeneous mixtures are also called as solutions. Okay, these are one kind of mixtures. There is one more kind of yes, here they are showing some examples for the homogeneous mixtures. Let us see them. All alloys such as brass and bronze, sugar solutions, air, and air is a solution because it has so many gases mixed in that. See, alloys like brass and bronze, they are made up of more than one kind of metals actually, but they seems like one metal, isn't it? And sugar solution, it is made up of water and sugar, but it seems like one liquid. And even air. Air is a mixture of so many gases like carbon dioxide, oxygen, nitrogen, and water vapor, and etc. So these all will come under homogeneous mixtures. Okay, next kind of mixtures are heterogeneous mixtures. The mixtures in which various constituents are not mixed uniformly are called heterogeneous mixtures. For example, if you see here the mixture of oil and water, if we take some quantity of oil and water into a glass, if you mix them thoroughly with a spoon, will you observe the mixing of those two liquids? No, they won't mix each other. They form two separate layers. The denser water will go down, whereas lighter oil will be floating on the water. This kind of mixtures in which the components are not mixed properly, not mixed uniformly, are called heterogeneous mixtures. Okay, so a heterogeneous mixture does not have uniform composition throughout its mass. Yes, there is no uniform composition. They won't be mixed properly. Such kind of mixtures are called heterogeneous mixtures. So it has visible boundaries of separation between the various constituents. Yes, here the components can be seen visually. If we observe this same mixture here, the mixture of water and oil, we can see clearly water and oil separation, isn't it? Yes, they are seen clearly. Such kind of mixtures are called heterogeneous mixtures. Let us see some examples for these heterogeneous mixtures here. Sand in water or muddy water, kerosene oil or any other vegetable oil in water, and paints, soil, and dissolve will come under heterogeneous mixtures. Because if you see the first one, sand in water, we can see the sand particles clearly through the water. In the muddy water also in the same way, mud particles can be seen clearly. So this comes under heterogeneous mixture. And next one, kerosene oil or any vegetable oil in water. Just now we have seen oils won't be mixed into water. So now we can say oil will be floating on the water and can be seen clearly. And if you say soil, even soil also made up of so many components. If you take some soil into hand and if you observe, there you can say some clay, small stones and pieces of grass and some insects, sand. These all will be seen through the soil, isn't it? So hence, these all will come under heterogeneous mixtures. Okay. Next, what is the necessity of separation of substances? Let us see here. Before going to say that different separation techniques we use in our daily lives, but first we have to know what is the necessity, what is the importance of separation of substances. Let us see that here. Taking out useful substances from a mixture is usually the main reason for the separation of substances. Yes, actually, in a mixture, we might have some useful components and some unuseful components. Then, from those mixtures, we need to separate these useful components. That's the main necessity of separation of mixtures. Sometimes, we also need to separate substances when we need to use different components in different ways. Of course, not always useful and useless components may be in the mixture. Sometimes both the components also might be useful to us. In those conditions also we have to separate them and then we can use those components in different ways and different purposes. Okay. So let us discuss some simple methods of separating substances that are mixed together. You may come across some of these methods being used and seen in our day-to-day life. Okay, now let us see here some separation techniques. Some of these will be observed in our daily lives also. See here different separation methods or methods which we use for separation of substances. One among them is hand picking, sieving, threshing, winnowing. So these techniques we are going to see now. So first one, hand picking. It is the simplest method of separation substances. This method is used only when unwanted material is in small quantity. Moreover, shape, size, or color of the unwanted material is different from that of the useful materials. Okay, then only we can separate the mixture by using this hand picking technique. So there, the quantity of this unwanted material will be less. Then we can separate them easily. And even there should be slight difference in their shape or size or color. Any one of these will be different from the useful material. For example, say in our homes our mothers will be separating some small stones or any stones or some other insects present in the rice by hand picking method. Before cooking that they will separate this all, isn't it? So, for example, pebbles, broken grains, and insects are separated from rice and even from wheat also, and pulses by hand picking method. By this method, we can separate these. Okay. Next, one more method, sieving. When the size of the particles is too small to be picked up by a hand, or when the quantity is too large, sieving is used for separating substances. So actually in hand picking method what we told, if the quantity of the unwanted material if it is small, then we can prefer that hand picking method. Slowly we can remove those all unwanted particles by hand picking. Okay, so there will be slight difference in their size or color, some other physical property. But if the quantity of those unwanted particles and wanted particles if it is being more, So the hand picking process may not be possible because it may take a long time if you do that. Then we prefer this sieving method. Okay. See, this we observe generally in our homes also, isn't it? A sieve having holes of proper size is used for separation of the unwanted particles. The bigger particles are remained by the sieve, whereas the smaller ones pass through it. Isn't it? You might have observed this technique even at our homes also. So before cooking these rotis and this all, what they do? They will separate the insects or any small pieces, other unwanted particles present in the flour by using this sieving technique. So yes, they have given the example here. For example, this method is used for separating brown from flour and sand from gravel. If you observe at a construction of buildings, there they will be separating stones and some other unwanted particles present in the sand by using this sieving technique, isn't it? Yes. Next, threshing. Threshing is part of the harvesting process. Yes, it is one of the techniques which is followed by uh, farmers in the harvesting process. The stacks of harvested crop are thrashed against a slab of rock is called threshing. So what they do after cutting the crop, they will beat this crop against a slab or any hard rock. Then the grains stick to that, they will be separated. This method is called threshing. The grains are separated from the straw by impact when the crop is beaten against a slatted bamboo or wooden platform or any other hard object such as a steel drum. Okay, any one of these will be taken and the straw is beaten against, then the grain will be separated from it. This process is called threshing. Okay. Next, winnowing. When the mixture is allowed to drop from a certain height. So the mixture which is obtained in the threshing process, what they have done in the threshing process, the crop is beaten against a hard rock. Then the grains are separated from it. That is called threshing process. Along with the grains, sometimes some other stones may come and even some grass also will be remained or some husk will be remained in the grains. So for the separation of these all from the grain, we use this winnowing technique. So what they do in that, when the mixture is allowed to drop from certain height, then lightweight constraint is blown away by air and a heavyweight constraint, that is grain, is settled on the ground. So after threshing, what happens? Along with the grain, certain husk also will be mixed into the grain. So for the separation of this husk, they will take the mixture of grain and husk into a plate. Then they will drop this mixture from certain height. Then the lighter weight husk will be blown away, whereas the heavyweight grain will be settled down the ground here. So they form two separate heaps. In this way, lightweight husk is separated from grain by the process called winnowing. Okay, this process of separating is a mixture is called winnowing here. So this technique included using a flat basket shaken to raise the chaff on a pile of harvested grain. Yes, they have used a flat basket here. See, this is flat basket is used. So into this, the mixture of grain and husk is taken. Then on standing on the certain height, they shake this flat basket. Then the mixture will be falling down. While falling down, the lighter weight particles will be blown away because of air, and this heavyweight grain will be separately fallen as a heap. In this way, grain and husk are separated by using this process winnowing. Mostly this process is used by farmers in the cultivation, in the harvesting process. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.